Hi everyone, welcome back. We are continuing Module 3. We are in Topic 1, Lesson 2. We're on Activity 1. We're starting on page 361. Writing expressions with variables. You can write expressions even when a number is unknown, and habits of mind, reason abstractly and quantitatively, construct viable arguments, and critique the reasoning of others. A school lunch costs $3 for each student. For each situation, write a numeric expression to determine how much money the school collected. Then evaluate the expression. So that means we're going to solve it. Okay, so it tells us 55 students purchase a school lunch, and we know the school lunch costs $3. So if 55 students purchase it, and they each pay $3, we're going to do 55 times 3 for a total of $165. 126 students purchase the lunch. So we're going to do 126 times 3, which is equal to $378. And you could do 3 times 55. You're going to get the same thing. Or 3 times 126. You can switch those around, it's okay. 1,512 students purchase a school lunch. So 1,512, still multiplying by $3 for each student. So we have a total of $4,536 for that. So write a sentence to describe how you can determine the amount of money collected for any number of students buying lunches. So let's see, what did we do? So we took the number of students buying lunch and we multiplied it by 3. So we could say we multiplied the number of students buying lunch we could even just say the number of students. Well, I guess we should say buying lunch by the cost of the lunch. For here, that was $3. Okay, it says in question 1, there's one quantity that changes or varies, and it's the number of students who bought school lunches. Recall in mathematics, you often use letters to represent quantities that vary. These letters are called variables, and they help you write algebraic expressions to represent situations. An algebraic expression is an expression that has at least one variable. So I want you to circle, highlight, just, bubble around, whatever, right here. Okay, so then it says, write an algebraic expression to represent the total amount of money collected for S students buying school lunches. Okay, so now on the last video, we did numeric expressions. So we did these with just numbers. So how are these different from algebraic expressions? So in an algebraic expression, there's a variable. It's really the only difference. Okay, so it tells us to use S. So what did we do each time? We took S and we multiplied it by 3. The way that you'll see this written in mathematics is the numbers first, followed by the variable. So 3 times the number of students. Remember, when a number and a variable sit side by side, it means multiply. You call a number a variable in an algebraic expression a coefficient. Highlight, circle, box, do something here. If a coefficient does not appear in front of a number, this should say variable. Change this, please. It's an error in the book. That should say variable. If a coefficient does not appear in front of a variable, it is understood to be 1. So the coefficient of x is 1, because how many x's did I write? I wrote 1x. There's no need to put the 1 here when I can just simply look at it and see that there's 1x. Identify a coefficient in the expression you wrote in question 3. So we wrote 3s. So what's the coefficient? It tells us you can call a number multiplied by a variable in an expression a coefficient, and we're multiplying this number times this variable. Also tells us if a coefficient does not appear in front of a variable, it's understood to be 1. So here it's also in front of the variable, so the 3 is our coefficient. Okay, pause if you need to. I'm going to flip the page, keep the video shorter. The cost of renting a skating rink is $215 for a 2-hour party. The cost will be shared equally among all the people who attend the party. For each number of attendees, write a numeric expression to determine how much each person will pay. Then evaluate the expression. Okay, so the first one is kind of sad. It says 1 attendee. Well, you can't really have a party with just 1 person. So if this 1 person shows up, then I guess they're paying for all of it, right? So we're going to do, for each of these, we're going to set up our ratio as cost per person. Because remember, we put money in the numerator in most all instances. So $215 per 1, well, we'll say 1 person. And then when we evaluate it, 215 divided by 1 is that person pays $215. Okay. And letter B. So what if there's 215 attendees? So it's a $215 cost, and there's 215 people. So then we have 215 divided by 215 is $1 per person. $10 attendees, so we have $215 being divided equally amongst 10 people. Our cost per person there is $21.50 per person. Okay, letter B, or D, I'm sorry, says write an algebraic expression to represent how much each person will pay to attend the skate party for P people attending the skate party. So the number of people being P, here it was 1, here it was 215 people, here it was 10 people. So it doesn't matter how many people there are, we're going to take the $215 and divide it by however many people there are. So, look, they told us to use P for people here. And what does the P represent? P represents the number of people attending. Okay, Jimmy has 300 credit gaming cards to use at the arcade. Complete the table to determine how many credits remain on each card after playing games at the arcade. So if he started with 300 and then he used 33, how many does he have left? Well, I would do 300 minus the 33. That would give him 267 credits left. 300 and then 57 used. I'm going to subtract that. It's 20 more than there, so I'll have 20 less left, so 247. And then if he used 77 credits, it's 20 more than that, so he's going to have 20 less left over, 227. Oh, nope, I'm sorry, hold on. I made a mistake. It changed from a 3 to a 7. So look, 300 minus 57. I thought it was 37, 57. So 243 and then 223. My apologies. Write an algebraic expression that represents the number of credits remaining on each card after using C credits. So he starts with 300. Each time we subtracted the number of credits he used. So we have 300 minus C. So why is it not C minus 300? Because C represents the credits being used. And he's not using a certain number of credits and then subtracting 300. That just doesn't make sense. So 300 minus C. Moving on. Write an algebraic expression to represent each situation. Ben is selling tickets to the school play. How many tickets will he have left if he starts with T tickets and sells 125 tickets? Okay, so he starts with T tickets. What does T represent? So T is the number of tickets he starts with. So tickets he starts with is our T. How many will he have left if he starts with T and sells 125? So if he sells 125, he's going to subtract that from here, and that'll tell us how much he has left. 125 is not a coefficient here. It's not attached to this variable. You call a number that is multiplied by a variable in an algebraic expression a coefficient. We are not multiplying the 125 times the t. We are subtracting it. Letter B, a plane descends to 5/6 of its cruising altitude. What is its new altitude? Okay, so I see a little math word here, of. So that means multiply. So 5/6 of its cruising altitude. The altitude is A. So 5/6 times A, we will write it as 5/6A. Okay, so that is our key word. Our coefficient here is 5/6, and yes, a coefficient can be a fraction or a decimal. Game downloads cost $6 each, with an additional membership fee of $10.75. What is the cost of X downloads? So they mean total cost overall. So total cost. So not just the downloads, but the downloads and this additional fee. So we have X for the downloads. So every time we download, we're going to pay an additional $6. So if we did one download, it's $6 plus the $10.75. If we did 2 downloads, it's 6 times 2 plus the $10.75. If we did 10 downloads, we would have to multiply the 10 by the 6. So we're doing $6 times the number of downloads, but then we can't forget about that membership fee we have to add on. Headphones cost $35 and portable music players cost $75. How much does it cost to purchase X headphones, and why portable music players? Okay, so we're buying a certain number of headphones and a certain number of portable music players. The question doesn't really specify if we're buying both. I'm assuming that we are. So if we're going out and buying headphones, so this is the number of headphones. X is representing the number of headphones, and Y is representing the number of portable music players. So we'll do $35 times however many headphones we buy. And for the portable music players, we will do how much? $75 times however many of those we buy. And if we are buying both, we would add those together. think that takes us to the end of activity 1. It does indeed.